To help me out with my weather station project, DFROBOT have been kind enough to give me a SEN0500 sensor. This is an aggregate sensor for temperature and atmospheric pressure and light level measurements. They provide support libraries for Arduino and ESP32, but of course I'm going to do this from a Raspberry Pi Pico. Let me tell you how I got on. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Remember to subscribe and join the community. I plan to use this sensor as part of my weather station for atmospheric pressure, UV and ambient light reading. I don't think the temperature sensor reading will work for me though, due to my deployment environment, let's say. I'll explain that a little later in the video. If you like this video and it helps your learning or projects, why don't you drop me a cash tip using the super thanks button below the video. I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there, and I hope to see you there too. Please hit the like button on the video and subscribe for more. The DFROBOT SEN0500 is an aggregate sensor. It provides temperature, humidity, atmospheric pressure, UV and ambient light measurement. Has two interfaces, so you can either read this using UART, serial communication, or I2C. This video is sponsored by Kunkune. Kunkune are a friendly UK retailer for electronic components, modules and tools. Kunkune have kindly offered you a 20% discount off your first order. Just quote code Dr Jon EA Ltd at checkout. This excludes tools and test equipment. So next time you need that module, breadboard or pack of LEDs, go check out Kunkune. The SEN0500 is a 30mm by 20.5mm module. It's got 6 connectors on either side. One side is for the UART connectivity, one side is for the I2C connectivity. Of those 6 connectors, 2 are not connected, so really it's only 4 pins. It's a 3.3 volt device and it draws 35 milliamps, which is a fair old whack for battery powered projects that I'm thinking of. Connectivity is I2C or UART, and you have a choice of which way to go. I must admit, when I talk about this later, in the way I have ended up going is all I2C. The UART protocol is complex. So this device is really an aggregate sensor, and it uses a bunch of other sensors and then pulls the data from them and then provides that as a single unified interface. So we've got an atmospheric pressure sensor, which is a BMP 280, a temperature and humidity sensor, which is the SHTC3, UV sensor, which is this ML8511, and an ambient light sensor, which is the VML7700. So all of those sensors and the data from them is then presented into a register map that then can be read via the I2C or UART interfaces. So we've got, first of all, the version number of the firmware that's running on this device is available at register 5. You've got UV intensity in milliwatts per meter squared on 8, ambient light, etc. So all of those are really all we're going to do is just interface to read those values back. Now they're not really entirely in those units. There is actually some conversion that is needed to go on, because it's a derived version of those units that is actually being provided by this, and I've had to do some reverse engineering of the code to work out some of that. So the two ways of talking to this are either I2C or UART. I2C is pretty standard, just sending the register number and actually reading that DAC off the bus. The only gotcha I think I found in that, apart from needing to do a little conversion to get things into the actual correct units, was that the registers are actually multiplied by 2 into what you actually send down to the chip, which sort of surprised me a little bit. But anyway, once I worked out that's what I was doing, that was all very easy. The UART protocol is very proprietary and not documented anywhere I could find. So I could try and reverse engineer this from their code, and I did try to do some reverse engineering from their code, not successfully, I must admit. So yes, I haven't got UART working, which is a shame, because actually that's one of the things I was originally planning to use on this. From a software support point of view, DFROBOTS support Arduino and ESP32, and that's what their code libraries will work with. Now that's a bit of a problem for me, because obviously I want to do this stuff on a Raspberry Pi Pico or RP2040 board. So I've had to actually go back and actually write my own. So don't worry, there is a library here, or there is at least a class that I've got in the middle of my weather station code that will work and interface to this device in I2C mode and will allow you to read all of that data. So over on the repo, I'm just going to show you this class that I've written to work with this sensor, the Sen0500. So here is a class, and what I've basically just done is a constructor and then methods to read temperature, read humidity, read the UV, read the luminous level, and the version code. And I've got everything converting to the right units there, or a set of consistent units from what is actually returned by the chip itself. So if we have a look at the test section of my weather station code, because this is just all embedded in the weather station code, sorry. Here we go. So I've got a test here which is just going to initialize this sensor. It's going to give it where it makes sure that the GPIO pads are set up for I2C that it's attached to, and that's all set up and working. We'll initiate our sensor, and then I'm just going to read 10 times. Actually, I suppose I should mention that there's a little bit of a delay here. I'm powering on this sensor because I'm actually got power control in my environment for this, and when it's turned on it takes about 10 seconds before you start getting valid readings for it. So just be aware that it takes a little bit of time for it to start up. So I'm just delaying there while it starts up, and then I'm going to read temperature, humidity, pressure, UV and luminance level for 10 times and print them out. So this is the demo, and it's just initializing the device and waiting for that 10 seconds, and then we'll start reading the levels. And you can see that actually it's quite dark in my study and on my bench. So let's turn the light on, and we will get a spike in the light levels up to lux level 4, and then turn the light off again, drops back down to lux level 1, lights back on up to lux level 4 again. So what's my appraisal of this device? Well, as an aggregate sensor, it's really quite nice. It's really quite useful having those sensors and the discrete electronics they require around them all done for me on a module, and all 4 of them all sorted out so that I can just interface to it once with just those 4 connections as well. The lack of documentation around the UART protocol is kind of frustrating, and trying to reverse engineer that from their source code was really actually quite hard work. So that is a problem. This is not as documented as I would like, and that seems to be a common problem with this sort of hardware. The final bit I would say is the one that has made me think a bit is around temperature and UV. Should they really be on the same device? Certainly I would probably be having them on completely separate boards if I was designing this for my weather station. And here's a bit where you get to have a laugh, because I am doing this for my weather station. I'm trying to actually have these services available. That means I need my sensor to be exposed to the sunlight so that I can see how the brightness and UV levels are. So my sensor is actually going to be inside a jam jar, basically, So this is where I confess that, you know, really I am at times an amateur, because this is all I have available to me. So it's going to be in a jam jar sitting on top of a Stevenson screen. Because it's in the jam jar, because it's going to have UV and sunlight hitting it, of course the temperature sensor is going to completely useless to me, and the values it will be reading will be way high. So yeah, not going to be able to do that. Instead, actually, I'm going to use an AST10, which is going to be in the middle of the Stevenson screen and actually giving me a true temperature and humidity reading. So yes, UV and temperature on the same device, not sure, certainly not for my weather station use case. Certainly in my tests, and when used with an I2C device, this works quite nicely. For my battery use case, I've had to add some power management to cut the power to the device while the Pico is asleep. I'll be talking about that design and all the other design challenges for my weather station in a playlist of videos. Why not check them out? Remember to stay subscribed so you don't miss my next video. If you'd like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there, and I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.